Hello everyone and welcome to this new tutorial on test-driven development and behavior-driven development using Cucumber and Spring. I will quickly verify the version of Maven installation on my system, and for that I have typed in Maven version, and 3.6.3 is the version that we will be working with in this tutorial. Next, I'll just create a new directory that I would call java and then bdd. If I navigate over inside java-bdd, I should see no files exist. So I'll just do ls in this directory and there is nothing currently existing. Now let's go over to cucumber.io and follow the 10 minutes tutorial to just identify the steps for creating a new Maven archetype by calling cucumber archetype. So I'll quickly copy the command and move over to my terminal and paste this command by just modifying the artifact ID, group ID and the package name. So I will just head over to the package section and call it java-bdd, and after this I will just modify the artifact ID to be something like CodeGeeks java-bdd, and I'll paste the same for the group ID. So after this I'll hit enter and wait till the project creation successful. Until the project creation is in progress, let me talk about the use case or the feature that we would be developing. So basically we are going to be developing a banking application wherein a user can withdraw amount from his or her account if the minimum balance requirement is met. So I have already copied two classes which are bank account and withdraw balance. Let's see. The bank account has just the three fields. One is the account ID, then account balance and the minimum balance requirement. Let me quickly create the getters and setters for these attributes, and once it is done, I'll quickly create the constructor that takes in the account ID as the only parameter to initialize a bank account object. If I move over to withdraw amount or withdraw balance class, herein I'll be having a single property that's bank account, and for any withdraw balance object to exist, it will always take in a parameter of bank account. So I'll create the constructor that takes a single argument called bank account. Before starting with TDD, I would first like to give credit to this particular website from where I'm taking the reference. And as in here, it says that TDD is nothing but TFT plus refactoring, wherein TFT is test first development. So by the suggestion of the blocks here, we are first going to be writing the test case, and we are going to fail with the test case, and then we are going to be adjusting our feature definition or our implementation, and then this loop continues until we have the test case as a success. Okay, so let's do that. Okay, as the steps were suggested, first we are going to be defining a test case called banking test. And this banking test was going to have a single function, and this function is basically going to be called something like test withdraw, and okay, and this test withdraw is going to be basically testing the proposed feature. Okay. So let me first create this object of bank account and sets few properties like the account balance, which is going to be something like 1000, and then I'll also set the minimum minimum balance requirement, which is something like 100, and then the withdrawal limit for this particular bank account is going to be 1000 minus 100, so up till 900. Okay, so now I can create a withdraw balance object, and withdraw balance object is just going to be taking in the bank account object as its only argument, and then I can just perform the withdraw amount function on this particular object. So withdraw function can actually withdraw some amount that we pass as the argument of the withdraw amount but there is a clause that the minimum account balance has to be met. Otherwise the withdraw is not going to be successful. Next, I'll just write in the feature, and the feature would be a public function called withdraw amount, and withdraw amount is going to take in an integer as its only parameter, and that's the amount. To make this whole feature a little more simple, I would say I'll return a 0 value. So let me return a double from this function, and it's going to return something like 0.0 if the conditions are not met. However, if the conditions, which are that the amount that the user is trying to withdraw must be lesser than the account balance, or the account balance is greater than amount, and the second condition, which is that after the amount is withdrawn, whatever the remaining balance, that should be greater than the minimum account balance. So if these two conditions are met, then a successful withdrawal is allowed. Okay, so let me write this condition. The first part is calculating the remaining after the amount is withdrawn, and it should be greater than or equal to the minimum balance. So if this condition is met, we will let the user withdraw the amount, and let's just return the amount. However, I can return int from here, but it doesn't matter. So with this, the definition of our feature completes, and now we will go back to the test case. So in the test case, first I will try to give a number that I want to withdraw, and then I will try to give an assert statement. If I try to withdraw something like 950, then this should fail basically, because 950 is not allowed until 900 is the maximum amount that is allowed. So I'll try with 500, and 500 should succeed, because even after withdrawal there should be 500 remaining, which is greater than 100. So 901 is also not going to be allowed. So let me try that as well. 901 should fail. I will bet for that, and it fails. So let's go back to the previous version wherein our test case passes. So this is basically doing a test or a unit test for our feature. Okay, now if the product owner asks for the behavior testing or the feature testing, unit test is not going to work. And in that particular case, what we need is basically writing a feature testing we call behavior driven development. So to achieve behavior driven development, what we are going to be doing is that we are going to be creating something called a feature file. And the feature file would be created inside the resources directory under the test directory. So let me make it something like withdraw.feature, and withdraw.feature is going to be defined here. Okay, so now we are into the Wikipedia page for behavior driven development, and if we focus on the definition, then we can see the different actors for doing behavior driven development as they are highlighted here. There are QAs, developers, and all other different actors of software development who can be the stakeholders. Now, how behavior driven developments are written? They are basically written as I'm highlighting here in some English-like languages. So if this part is not clear, there is an example here in this particular page as well. So I'll scroll down a bit, and then we will see that there is an example wherein a BDD use case or a BDD have been written. So basically at the beginning, the description is placed, and then different scenarios are kept. Now scenarios are basically all the different scenarios or use scenarios for testing, and then there are some steps. For example, then these are all the conditions that are written for writing any behavior driven development. Now we are going to be doing the exactly same thing on IntelliJ. So in IntelliJ, it starts with defining the feature, and in the feature we will write the description, which is withdraw amount safely by not crossing the minimum balance in account. Okay, so this is basically overall my feature description. Now I will have to start writing the scenario, and there could be two scenarios basically. One scenario could be wherein I write withdraw amount safely, and I can also write apart from writing this scenario something like withdraws amount unsafely. But first let's define withdraw amount safely, and in the given we will say the current account balance is 1000, exactly how we wrote in our unit test while doing TDD. The next step is basically defining when, and when is going to be defining that when the minimum balance account or the minimum balance requirement is met. So I will write minimum account balance to maintain is 500, and after that we are going to be defining the then step. Now then step is basically for doing the actual execution of the function, which in our case is doing a successful withdrawal. Okay, let me edit the when section a bit more. So I would say successfully withdraw, and then I will pass the number. Say for example I want to withdraw 100, so I will say 100, and I have put everything in quotes because all these 1500 and 100 would be taken as a string in our step definitions. Now step definitions is a very important class because step definition is exactly working in conjugation with this particular feature. Now we are going to be defining the step definitions class. Now when we generated this project using Cucumber archetype, the step definitions.java was created. Therefore inside this class we are going to be setting up the steps. So we can already see the different imports for given, when and then are created. So first we are going to be defining methods, and then we are going to be mapping the different annotations like given, then and when. So the first function we will be calling as is account balance not empty, because that was our given condition. So we are going to be calling this function public void is account balance not empty or not 0, and then we'll be accepting one string argument. Now if we remember from the feature definition, we had 1000 passed as a double quoted string. Therefore we are going to be taking this mapping by calling inside the curly brace a string. Now the same format is going to be copied over for all different steps. For example, in when we are also going to take an input of the curly brace string, because for when we have passed 500 as double quotes, therefore we will all again define another method and we will call it is minimum balance maintained, and is minimum balance maintained is also going to take up the string input or string parameter, and the same is going to be defined for the then condition. So let me write the then function that takes in a string. Inside curly brace I will write string, and then I will again define another public void method for the then condition, and I'm gonna call it withdraw balance. Withdraw balance takes another string argument. So that's exactly how it should look like. Now we are going to be placing the withdraw.feature as a vertically splitted file so that we can take a look at it, and we are going to be copying over the string just before the actual number. So we are going to pass it here so that now account balance is and string will hold 1000 value. Same goes for all other steps. So we are just going to copy the rest of the string part and successfully withdraw as well for the then annotated function. Alright, so here we have now set up the class to receive the inputs from the feature file, but now we also need to map the same inputs to the bank account object like we did in the case of TDD. So we have now initialized the bank account object, and inside the given step, first we are going to be setting up the account balance by calling bankaccount.setAccountBalance and then pass the string to an integer and then pass the account balance string that it receives. In the when step, similarly, we are going to be defining the minimum balance requirement. Therefore, first we are going to need to call the set minimum balance requirement on the bank account object. Therefore, we will say bank account dot set minimum balance requirement, and similarly parse the string to an integer and then pass the minimum balance string. And lastly, we are going to be defining the then step. So first we are going to be initiating an object, and we call it withdraw balance. Let's call it withdraw, and then pass the bank account object to the constructor of the withdraw balance class. So we would say new withdraw balance passing the bank account, and now we want to assert the withdraw statement. So how we are going to be writing it? We'll say assert, and then we will say assert withdraw dot withdraw amount, and we'll pass some number, and the number would be exactly the amount that we receive. And after withdrawal, it has to be greater than 0, because 0, if we go back to the definition, 0 is returned for a unsuccessful withdrawal. But for any successful withdrawal, the amount is going to be exactly the amount. Okay, so this is going to be more or less the definition of the steps. So what we can do now is that we can run the mvn test command and verify that our feature works. So let me first verify. Yes, we are trying to withdraw 100, and this seems to be working fine because the minimum balance requirement is 500, so we can withdraw up to 500, and we are now just trying to withdraw 100 from the first scenario that we are testing, so it should work fine. Let me hit the mvn test command, and okay, now it's running. Soon we are going to be seeing that the tests are being run and the build success. So build success confirms that there was no error in our test configuration, and we can see that the first feature passes. Now what if we want to define the second scenario that we were talking about, which is something like withdraw balance unsafely? So we will just copy and paste the scenario here, and we will say unsafely. And what would be an unsafe withdrawal is that whenever the withdraw amount crosses something above 500, so for example 550. Now if we save this and if we just run the mvn test command, what we should see is that one of the scenario is passing, however the other scenario is failing, and that's exactly the output here. We see one failure out of all the 3 total runs, and yes, the failure is for 550 and it's an assertion error. Okay, if now we modify the scenario for the second scenario to be anything wherein the successful withdrawal is less than 500, for example 50, then both the scenarios should pass. Yes, both the scenarios are passing now, and we are good with defining the scenarios. So hopefully by this time it should make sense like how to define multiple scenarios.